In this question, we have to show the commutation relation of the Lx with position and the Lx of the momentum, and later then Lx and Ly and Lz and so on. So in the first part of the question, we have to show that the commutation of Lz with x is IH bar y, and starting from the uh, combination relation of the x and p, that is position, and the momentum, that is xpx is IH bar, and if we take the reverse, xpxx is equal to minus IH bar. Now in the a part, we have to show that Lx x is IH bar y, and for this we have to use the properties, that is a b c is equal to a b c plus bac, and second property is, that is a b c is equal to abc plus acb. We have to use these two properties, and we have to start from this x and the px. Now let's find the Lx and the x. As we know that Lx is equal to, sorry, this is Lz. First part is the Lz with x. Lz is equal to x py minus y px. And now take the commutation relation, that is x py minus y px, and the x is equal to, that is x py and x minus y px and x. Now I use this properties ABC, that means this is a x py and x plus x x and py. Similarly this one y pxx, and this will be minus ac, that is phi x and px. Now as we know this, the commutation relation of the py with the x is 0. So this part is 0 and this part is also 0, minus y and pxx in this, that is minus IH bar, and this is also 0. So hence this will be plus IH bar y, and y operator, that means the Lz with x is equal to plus IH bar y. Now in the second part of this, Lz with y, then we will write this Lz operator here, that is x py with y minus y px and y. Again we have to use that property, this one abc and acb, that is x py and y plus acb, that is x y and b py minus ypx, that is y px and y, and this is minus, and acb, that is y y and px. Now we know that x and this py, that is minus ih bar, and this is 0, and minus, and px with y is also 0, and this is also 0. So that means Lz with y is minus ih bar x. Now third part is Lz is with z, is equal to, that is x py z minus ypx and z. So here this will be x py and z plus x z and py. Similarly this pi ypx and z plus yz and px. So this value 0, this value 0, so all are 0. That means Lz commute with z. Now in the next part we have to go to the Lz with px. Is equal to, that is this value, that is x py minus y px into px. These are all operator. Now this will be x py and px minus ypx and px. Again use that identity, that means x py and px and this will be plus x px and py. Similarly, we will use this one minus y px and px minus y px, and this will be px. Now, to calculate this, we should know about this, the commutation relation of the px and the py. Now, as we know, the commutation relation of the py px is 0, so hence this value will be 0. This commutation relation is 0, and this, now, that is x, this part is 0 plus the commutation relation on the xpx is the ih bar, and py plus minus this part is also 0, and this part is also 0. So hence we got this plus ih bar and py. So that means lz and px does not commute with each other, and this value is ih bar py. Now, next part of this question, find out the lz with py. And this will be same, xpy with py minus y px py, and again we have to apply that properties, that is x py py plus x py and py minus y px py minus y py and the px, all are the operators. So here this value is 0, and this value is also 0, and this value is 0, and others are non-zero. That means this value is 0, and this value is also 0, minus 0, minus this value is not 0, this is ih bar, and this px. That means lz with py is minus ih bar px. Now next part is lz with pz. Is x py pz minus y px pz is equal to x p by pz plus x pz and py minus y px pz minus y pz and px. Now as we know, this value is also 0, and this value is 0, this value is 0, and this value is 0. So that means uh, this Lz with commute with Pz. Now the second part of this question, we have to use all these results and then show thus that is Lz with the Lx and the Lz with the R square. Now we have to show that the commutation relation of the Lz with Lx by using the result in the question number A. So here Lz with Lx, that is Lz is xpy minus ypx and Lx is ypz minus zpy. So from here we starting from this Lz with Lx is equal to Lz and the ypz minus zpy is equal to that is Lz with ypz and Lz with zpy. Now apply the property, that is Lz with y pz and plus y Lz pz minus Lz zpy minus z Lz py. As we know from the part A, that is Lz with y is minus is bar x and pz is as it is y. Lz pz is 0 minus Lz with z is 0 and py minus z, and the commutation Lz with py is minus is bar px. These results are determined in the part A. This value are already calculated. Now this value is minus is bar x pz plus this minus plus, that is is bar z px. Now this will be is bar z px minus x pz, and this is nothing, this is the value of the Ly. Now next part is Lz with r square. Let's find out Lz with r square. And r square is nothing, it is x square plus y square plus z square. Now we have to distribute this Lz with x square plus Lz with y square plus Lz with z square. Now we have to first calculate Lz with x square, and this will be Lz and xx. And now apply the property here which is given at the upper part question. This ABC, that is ABC plus BAC, because this is LZ and this is XX, that is X square, ABC plus BAC. So here A, B, C, and this will be LZ and X plus BAC, B is here X and A is LZ and C is x. As we know, the value of the Lz with x is from part A. Lz with x is IH bar y, and this is x plus x, and this is IH bar y, and this will be 2IH bar xy or yx because they commute to each other. Xy is equal to 0, that is xy minus yx is equal to 0, or we can say that xy is equal to yx. Similarly, Lz with y square is equal to Lz y y plus y Lz y. Now use the result of the first part A, that is Lz with y is minus IH bar x and y plus y minus IH bar x, and this is minus 2 IH bar xy. Similarly, Lz with z square is equal to Lz z z plus z Lz and z, and this is 0. So hence Lz with r square is equal to, this is plus 2y bar xy and this is minus, so hence this will be 0. So this is part C. And now calculate Lz with p square. Similarly, we have to calculate Lz with p square, and it will be Lz px square plus Lz py square plus Lz pz square. Now calculate first this one, that is Lz px square is equal to Lz px, and now use the property, that is ABC Lz, uh, this property AB Lz px and plus BAC, and B is px, that is Lz px. Now use the result of the part A, that is Lz with px. Lz with px is IH bar py, and this px is as it is plus px, and this is also IH bar py. So this will be IH bar py px plus px py. Similarly, we can calculate Lz with py square. it is Lz py plus py Lz and py. Now use the result from the part A. Lz with py is minus is bar px minus is bar px py plus py minus is bar is bar px. So this will be minus is bar px py plus py and px. Now calculate Lz with pz square is equal to Lz pz and pz plus pz Lz and pz. As we know, this value is 0, this is also 0, and this is also 0, so hence this value is 0. Now Lz with p square is equal to, as you can see, this is positive p by px plus px py, and then hence this value will be 0. Now we have to show that this Hamiltonian commute with all three components of the angular momentum, that is h lx, h ly is equal to 0, h lj, and here v is dependent of the, this operator is er. Now let's find out this h with lx first, and this will be, that is p square by 2m plus v, and lx from here, that it will be p square by 2m lx plus v lx, and this will be v lx minus lx vx, that way it will be 0, and it will be 1 by 2m p square and lx plus v lx. As we know that this p square is commute with lx, as we show in the previous, that was p square, and the lx commutation relation is 0, and we show that Lz p square is 0. So here we can prove that this p square lx, uh, let's find out this value first. So this p square lx is equal to p px square and lx plus py square lx plus pz square lx. And now this will be, that is pxxx, that means pxx lx is equal to, and this will be abc, that is px lx plus ACB EX and LX and B is PX. And from part A, we know that the PX and LX. Oh, that means we did not calculate this value. That means this commutation is also 0. So this is 0. Similarly, we can calculate P by Lx and P Lz, and because this Lz commute with P square is 0, similarly Lx with P square is equal to 0, and Lz or Ly P square is equal to 0. So hence this commutation relation H with Lx is equal to 0, because this value P square Lx is 0 and Vlx is also 0, because V depends upon the position R only. So this value is 0. Similarly, we can calculate H Ly, and this will be 1 by 2m P square Ly plus V Ly. This part is already 0, and this similarly P square Ly is also 0. So hence this value is also 0. Similarly, we can show that H Lz is equal to 1 by 2m P square Lz plus V Lz, and it is also 0. So hence we already calculated this value. This is 0 plus 0. So hence it means that Hamiltonian commute with each component of angular momentum. Thank you.